I'm going to give an introduction to linear equations with variables on both sides, and you'll see what that means as we go along here. But before we get started, I'd like to give you a quick introduction to why you would do that. I've prepared a problem here to kind of get us going. Suppose you've got an online business that will help video game players through difficult situations for a small fee. They offer you two different ways to pay. Plan 1 allows you to simply pay $2 for every 10-minute block of time you spend, although they will round up. So 23 minutes, for instance, will be considered 3 10-minute blocks. So they'll charge you $6. Okay? But if you think you're going to spend a lot of time, it might be better to go with Plan 2. You got to pay $20 up front, but then it's only 50 cents for each 10-minute block. So when's it going to be a better idea to go with Plan 2? Clearly, Plan 2 wouldn't be a good idea if you're only going to spend 23 minutes, because that costs you $6 here, but I don't want to pay $20 up front and then 50 cents for each 10-minute block if I'm only going to use 3 10-minute blocks. But let's try this. Suppose we use 8 blocks. Well, for Plan A, they're going to charge me 2 times $8, so 16. Not Plan A, excuse me. Plan 1. Okay. Plan 2, how much is it going to cost me? Well, $20 up front and then 50 cents for each 8-minute block. So 50 cents times 8, that's 4 plus 20, so $24. Okay. Still not a great idea to go with Plan 2. They charge you a lot more. But what if you go up to, say, I don't know, 20 blocks? Well, 2 times 20 is going to be $40. Okay. Let's check out Plan B. Here's your $20 up front plus 50 cents for each of the 20-minute blocks. 50 cents times 20 is 10. This one only costs you $30. So at 20, it's a better idea to go with Plan 2. So somewhere in between 8 and 20 is going to be the sweet spot where it's going to switch over to Plan 2 being cheaper. Well, we can keep guessing and checking until we finally get the right answer. But algebra allows you to get to stuff like this quicker. Suppose we say, you know what, let's just take a guess that we're going to use X blocks. You could use X, you could use N, I don't really care which one, but I know that for Plan 1, it's going to be 2 times X dollars, isn't it? Okay, just like it was 2 times 20 or 2 times 8. Okay. Over here, it's going to be $20 up front plus 50 cents for each of your X blocks of time. Okay? So what our goal is then is to have this side equal this side. I want to find out when is Plan 1 going to be the same for Plan 2, so I'm going to stick an equal sign in there. And what I've done is written an equation that could now be used to solve. If I solve this, I'd find out what X is. Well, this might be new to you. It's got variables on both sides, and we're going to talk for the rest of this video about how to solve an equation like that. Okay. We're going to focus on basic equations and then ones that need to be simplified first. So here's our first one. Notice now it's got a variable on both sides. That might be new to you, but here's what we're going to do. We're going to say, look, I could make this equation look a little bit simpler by using some stuff that I've done before in equation solving. I know, for instance, that if I added 4 to this side, that negative 4 would go away. But you know better than just adding 4 to one side without adding it to the other, so we'll put it over here. And now, on this side, I've got a 15, plus I still have a 7n. Okay? And on this side, I've got a 2n. By the way, I oftentimes ask my students, why didn't I add the 4 to the 7n instead of the 11? Well, the 4 doesn't have an n on it. the 7n does. I can't combine terms that are not like terms. So I have to add it to the same type of number. 11 doesn't have an n, neither does 4. Okay. Well, I still have this problem of having variables on both sides. But here's the deal. Notice that I've got all of the non-variable stuff on the right side. There's nobody over here on the left side without a variable. So here's what I'm going to do. I'm going to leave all the non-variable stuff on the right side and get all the stuff with variables onto the left. So that 7n right there, he's going to go away. How do I get rid of him? Well, it's a plus 7n right here, so let's subtract 7n from each side. Okay. Now, simplify a little bit. This side still has a 15, but nothing else. This stuff has gone away. And 2n minus 7n, don't forget to subtract correctly. That gets you negative 5n. Now look at that. I'm down to a simple one-step problem that I've been doing probably for weeks in your algebra class. So I'll just say, look, I know how to get rid of the negative 5 off the front of that n. Since it's multiplied, I'll just divide it. That'll cancel it out. Of course, divide the other side by the same thing. That means n is going to equal negative 3. Okay? And if you put negative 3 back up into for n on each of these sides, let's see what we get. 2 times negative 3 is negative 6. Subtract 4 from that, you get negative 10. Over on this side here, 7 times negative 3 is negative 21. 11 plus negative 21 is also negative 10. So our answer is correct. Let's move on to another problem. This equation also has variables on both sides, but I know I can clean it up a little bit. And you know, this time I think I'm going to go after the stuff with variables first. And I don't know, I like to oftentimes get the variables on the left side and the non-variables on the right side. Doesn't really matter. So I think I'm going to get rid of this negative 2b. And of course, a simple way to get rid of a negative 2b would be to add 2b to it. Of course, I can't do that to one side without doing it to the other. I won't add it to the 14 because the 14 doesn't have a b. I'll add it right here. Okay. Well, remember, that's a 1b, right? Not just a b, it's a 1b. So 1b plus 2b is 3b. I still have a plus 14 over here. And over on the right side, I still have a 2. I got rid of the negative 2b, but I've got a 2. And of course, I'll bring my equal sign down. I like to keep it right below there so it keeps things straightened out for me. Okay. I'm not really close to being done. Well, I'm closer to being done, but I still have a 14 here. To get rid of a positive 14, so I have all the b's on one side and the non-b's on the other, I'll just subtract 14 from each side. Okay. Now on the left side, I still have a 3b. On the right side, I've got a negative 12. Okay. Now, to get b by itself, divide by 3 on both sides. So b equals negative 4. And if I check that, it'll still work. Well, if I look at new ones like this, same idea. I'm going to subtract 4x from each side probably, and I'll add 1x. I'm sorry, add 1 to each side to get things to happen there. I could also subtract 5x from each side, but that would get all my x's on the right, so I'd need to get my non-x's to the left. Okay. Well, the other kind of problem that we see, notice that this one says basic ones. The other kind of problem we see are ones that need simplification. Needing simplified first. So what I'm going to do before I can start adding and subtracting things from each side is I need to clean up these parentheses. Well, probably in your classes you've been doing this for a long time. When you see a number in front of parentheses, you take that number times each thing inside. So a negative 7 times a 3 is a negative 21. And a negative 7 times a negative x, careful, that negative goes with the x, gives you a plus 7x. I'm just going to bring everything else down here. And now I've got an equation with variables on both sides, numbers on both sides, but there's no parentheses. So here I go. I can take care of this. I think I'll get rid of the 5x from each side. That'll keep my x's positive. Sometimes I like to do that if I can. So look what happened here. Now I've got 7x minus 5x is 2x. I still have a negative 21 over here. This is positive, so I'll throw a plus sign in there. Bring my equal sign. Now be very careful. 5x minus 5x was 0, but I still have a negative 27 here. Don't forget that negative sign. A lot of people drop those things. Okay. Now, since I have all the x's on the right side, I'll get the non-x's to the left. Negative 21 can be gotten rid of by adding 21. And so now I have 2x here, my equal sign, of course. Negative 27 plus 21 is negative 6. Divide by 2. X equals negative 3. Okay. So I'm running out of time in my video. I'm limited to 15 minutes, so I want to look real quickly at another one here. This one, not only will I have to combine like terms here, that'll get me, I'll have to use the distributive property. But I'll also need to combine like terms right here before I can really carry on much. So I'll have to write 14a minus 1 equals negative 13 plus 2a. And then I'll carry on like I did before. Well, I want to run back to my other problem before I finish up here. This one, I'll let you finish it out. You're probably going to subtract 2a from each side to get all the a's on the left. You'll probably add 1 to each side to get all the non-a's on the right. Then you can divide. Okay. I want to go back to this problem right here and take a look at this equation that we had developed. Okay. Do you see now what we want to do? Okay. I'm going to copy that equation down to a new page here. 2x equals 20 plus 0.50x. Okay. Well, now I can solve this thing pretty nicely. Notice I have all of my non-x's on the right, so I'm going to get my x's to the left by subtracting 0.50x from each side. Okay. Well, 2x minus half an x is 1.5x, and this is 20. So now, if I want to find out what x is, just divide by 1.5. And 20 divided by 1.5, I've got a calculator right here that'll work for me. 20 divided by 1.5 equals 13.3, repeating. So it looks like at 13, it's going to be better to go with plan 1. Just above 13, it's going to be better to go to plan 2. Okay. So that's an introduction to solving equations using that have variables on both sides. Sometimes they get a little bit complicated, and you've got to do some simplifying first. Notice on this one I'd have to distribute and combine the k's later. So it's going to get, we're going to get started this way, and maybe write that as 10k plus 14. But after that, you can do things just like you did before of trying to get all the variables on one side, all the non-variables on the other, and then divide. All right, that's it. Bye-bye.